Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Copycat Burgh-lars. And it's by Chin Calv Sot Math Skoj. Or basically, these are these are pretty well known setters in the community. Chinstrap, we have Calvin Ball. Sotir, Math Guy 12, I believe it is, and Skojo. And they made a collaboration and they created this puzzle. So let's continue with the rules. We have normal Sudoku rules apply in the 9x9 grid, which is in every cell in the grid, we need to place a digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have periodic pill sums. Okay. Where a 2-digit pill clue outside the grid gives the sum of the first value seen in the row or column and the value of every nth cell after, where n is the value in the first cell seen. Okay. Pills are read from top to bottom or left to right using leading zeros for numbers less than 10. So that's what I was wondering about. It was basically... Huh. Oh. That is interesting. Wait, huh? Huh? I'm confused now. How does that work? Okay, so... Right, so... I am super confused then here. How are you ever going... Like, if you have a 9 here, it's the sum of that plus the 9th cell after, right? So wouldn't that sum always be 9? Right? Because you have that... If you have 1, then it's the first cell plus every first cell after, right? So that would be the sum of every digit in the column. But if you have 9, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, but there's no 9th digit. Huh, I'm already sort of solving this, but this is kind of confused. This is sort of clarification about how the rules work. And, okay, so the reason why I'm wondering about this is because of tentropy lines, right? Oh, we have copycat cells. Okay, right. Okay, that makes more sense. So yeah, if you did have a 9 in value, then it would be adding up the sum of these digits would be whatever plus the 9th cell, but there would be no 9th cell. So the value of this would be 0, 9 in that case, right? So that's how it would work normally in for these periodic pill sums. Or if we say we had 3 here. So that would be every third digit would be this. So this would be equal to the sum of this first cell plus every third digit. So if you had like 3, 6, and 8 there, then this would have to be what? 17, right? 3, 6 is add up to 9 plus 8 is 17. So if these were the digits in column 4, Excuse me. Something down the wrong throat there. That was weird. This would be the sum of the first digit plus every periodic digit afterward, which would be according to what n is, which is the first digit, first cell seen. The value in the first cell seen. So keep that in mind. And again, if we had, say, 9 as a value here, then this would be essentially 9 in value for this sum. And we'd have a 0 in the first part because the leading 0 works for 2-digit sums. Anyways, we also have tentropy lines, where every set of adjacent values on a peach line must contain a value from each of the x pairs, 10 pairs, subsets of 1 and 9, 2 and 8, 3, 7, and 4, 6. A value of 0 or 5 cannot exist on a line. So these are values, keep that in mind, not digits. And that's why I was getting confused, because here we had all tens digits, which none of them had a value of 0, right? Because you can't have 0 or 5 as a value on a tentropy line. And 9 would necessarily have to have the ninth digit be outside the grid, so it'd just be the sum of itself if it had 9 in value in the first digit here. So for example, you could have something like, say, 1, 6, 2, and 7. And this would be valid as a tentropy line because for every set of 4 adjacent values on the line, we have to have 1 from each of the subpairs, of the subsets, I should say, which would be 1 is from 1, 9, 6 is from 4, 6, 2 is from 2, 8, and 7 is from 3, 7. For lines less than length 3, all values must be from different subsets, which makes sense, right? Because it's basically just you have to have different subsets for every set of up to 4 cells, adjacent cells on the tentropy lines. But if it doesn't have 4, obviously you just have different subsets here. Okay, so this is the key component, which I was confused by. We have copycat cells, where we need to place 9 copycat cells into the grid so that there's exactly 1 copycat cell in each row, column, and 3x3 box. Each copycat cell must contain a different digit, so there are no repeats in the copycat cells either. And the value of a copycat cell is the digit in the cell rotationally opposite itself in the grid. 180-degree rotation about the center of the grid. So, for example, if row 2, column 3 is a copycat cell containing the digit 5, and row 8, column 7, contains the digit 9, the value of row 2, column 3 is the digit in row 8, column 7, right? The rotationally 180-degree rotationally opposite cell, right, around the center. So you figure that out by going 3 up here and 2 down, 2 to the left this way. That's rotationally opposite of 3 down this way and 2 right this way, which would be that cell there. So if this were a copycat cell, this would have a value of 9, which is the digit that's in row 8, column 7. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, as I said, because this is going to be interesting, I'm going to just randomly choose colors for these sets, particularly this one. This is the most this is the most important clue, I think. So We're going to make it light, medium, dark, and pink for the colors. Light, medium, dark, pink, light, medium, dark, pink, light, medium, dark, pink, and this is light. Okay. Entropy is values, right? Yes, values. So that means for the copycat grid, these are values here, not digits. For the tens digit, since you can't have 0 in it, that means they have to be the sum of the numbers in the column that we count periodically, which can range from 0 up to 45. So these digits necessarily have to be 1 through 4 here in value. Okay. You can have multiple. So the thing is, the 9 is going to have to be copycatted in this row. Since there's only one copycat, the 9 has to be copycatted because, as I said in the rules, if you have a 9 in value as normal value in row 9, that means it's counting the sum of itself and nothing else, which would mean it would have to have a sum of 9. So the 9 has to be copycatted to some other value. We don't know which. That means 8, 7, 6, 5, 4, 3, and 2, 4, 3, 2, 1 all have to be values for these periodic sums. 1, obviously, the sum of values has to be 45 because it counts itself and then every digit along the column. So 1 will necessarily have a value of 45. 2, let's just mark them all down. And there's going to be a repeat. 2 can have that. It's going to be every other digit, right? So every second one. So this one plus another one. Plus, so it skips out on. So 1 is basically the sum of everything. So it will count all of these. 2 is going to be these digits. 3 is going to be every third digit. 4, 1, 2, 3, 4, 1, 2, 3, 4. 5 is every 1, 2, 3, 4, 5, and then that's it. So how many? Let's count how many digits we have. We have all 9 in for value 1. We have 5 for value 2. We have 3 for value 3. 3 for value 4. 2 for value 5. 2 for value 6. 2 for value 7. 2 for value 8. And we are guaranteed to have these values somewhere in row 9. So that means the value of 5, 6, and 7, and 8 for the tens digit is always going to be 1. Right? Because two unique digits are never going to add up to more than 17. And so that means a tens digit is always going to be 1 because we can't have a tens digit of 0. So we need at least 4 cells that are the same. It's the same shading here. And that's going to be a 1. So if you have a shading of 4 or more, it's going to be necessarily a 1. And I think that's light. We have 1 light, 2, 3, 4. Mediums, we have 2, darks we have 2, and pinks we have 1. So that means light has to be a 1. Okay. Yeah, let's remove it from here. So we know then that these are all 1s. And this has to be 5, 6, 7, 8 in value there. Okay. 5 cannot be on entropy lines. So that's 6, 7, and 8. This has to be 1 or 9. So we have a guaranteed 5 here. And these are non-copycat cells. Okay, so the remaining sets are 1, 2, 3, 4, 5. 1, 2, 3, 4. No 5, right? 5 is 2. So that means we have 9, 5, 3, and 3. So 3 and 4 add up to at most 24. Actually, how is that going to even work? Oh. Right. 3 adds up to at most 20. 4 adds up to at most 21. And we have to have 3 and 4, and they cannot have a tens sum digit. A 1 in the tens digit. So that means 3 is going to be at most 20. We have to have then the dark be 2. So this is going to be 20, which means this must be a value of 3. So this is 20, this is 21, and this is a value of 4. And that fits for this tentropy line. So then this has to be 3, and these have to both be 4 here. There is no... How... Oh. Right. Because we have a copycat in each column. Right. Okay, so that's why this cannot be... So this is 42 or it's 48. It can't be... it could be 48. Because we could have a higher value. So this has to have a value of 1. This must be a value of 1. This has to have a value of 2 here. And is not the copycat. So these can't be copycat cells. So pink, again, must be 3 or 7. This must be 4 or 6. 3 here. This is 2 and 8 with it. And this is pink, which is 3 or 7. So we don't need the coloring here anymore. So we're going to remove the coloring here. This is not copycat, this is not copycat, and this is a 1-9 pair. Okay. Actually, is that the case? You could technically have 3, 9, and 9. Okay, hold up. No, this has to be, well... Okay, we don't know... So okay, this is not necessarily the case here. So this could be 0, 1, or 2 here. And this can be 3 or 4. We are not completely sure. Because of the copycat cells, right? Hmm. Yeah, okay, let's go back. Let's go back. Let's go back. Unfortunately, this has to be 21 though. Um this is definitely 21, but we don't know what this is. Ooh. This could be 3 or 4. 3 or 4, 3 or 4. Oh, we're gonna have to keep the coloring then. Okay, well. So if it's 4, I forgot about Copycat. You could have 9 and 9 in value, which is 18. So it's 20 to 22. This has to be 21 no matter what. But this could be 20, 21, or 22 here. We are not completely certain. We do know that this is not Copycat, and this is not Copycat. So this is 3 or 4 here, and this is 3 or 4 here. But we don't have enough information, unfortunately, to rule whatever I had out. 2 and 8, 2 and 8. This is 3 or 4, 6, 7, and we have 3, 4, 6, 7. Ugh. We're gonna have to keep the coloring too. So this is 1, 2, or 9. Um, hmm. What is the value you can have at most in 4 if you have 2 copycat values? So that's one thing I totally forgot. We can't have. You still can't. Okay, 1 through. So if you have 9 doubled and you remove the 2 from the 1, that's essentially a value of 2 going up to 9. So it's plus 7. 45 plus 7 is 52. So you could have 50 something technically, but the problem is that we have a entropy line, so it's not going to be. It's always going to be 40 something. So the value of 1, the value of the 5 through 8 is still the same. It's going to be a teen because you can't have 9 and 9. You can't even have a 9b as the first digit, as the first value. So it's going to be 8 and 9 at most for 5 through 8. Okay. Hmm. Okay, so 1 can be from essentially 30 something even, right? 1 through 8 plus another 1 in value is potentially possible. 1 through 8 plus a 1. That's 37. So minimum for 1 is 37 for with including copycat values. It could be 37. So 1 is going to be 37 to 52. Right? Because a 2 goes up to the 9. The 1 can't go up to a 9 in value because then you would skip all the digits in between. For 5 digits with 2, including a 2, the 6 could be replaced to be up to a 9. So it could be 2, 7, 8, 9, 9 as values. So that's the maximum. 9, 9. So it's 9, 8, 7, 24 plus 9 is 33 plus 2 is 35. So 35 is the max value. The lowest value, well, the thing is, it doesn't matter what the lowest value is. Well, maybe. Hold up. No, it doesn't, because we know 3 and 4 have... So this is essentially 30 is the lowest value. Okay. For 3, we have 3, 9, and 9. We know it cannot be a teen because all the teens are accounted for by 5 through 8. So the lowest value here is 20, and it can get up to at most 21. And for 4, it's the lowest value again is 20, and the most it could get is 22. Okay, so that means for the 2, it's going to be 30 through 35. All the possible 3s will always... Okay, so 37, it does... That could be 37. Okay, what is the value of the 9 that's copycatted in row 9? It has to be value 1 or 2. Okay. If it's value 2, the most you can have would be 2, 5, because the 9 basically is removed. You'd have 2, 5, 6, 7, 8 as the most you could have. 5, 6, 7, 8 adds up to 5, 6, 7, 8. Oh, and the reason why this is guaranteed to be a 2 is that, well, you could have a 2 there, technically. No, you can't. Okay, because again, the most you could have for 3 and 4 are 21 and 22 in value. And you can't have two... None of these are 21. So this can't be 21. This could be 21, but then this can't be 22. And it can't be 20 as possibilities, right? So both of them have to be essentially 2 with 0, 1, or 2 as a possibility. And this one cannot be, right? If this were 2, obviously this couldn't be 2 then, in that case. So it can't be 22. The 1s are already the light digits. So this is not possible to be 20-something on 20-something. So this must be the 20-somethings. So that's guaranteed. Okay. So if the 9 duplicated a 2, that would mean that the most you could have in that column would be 5, 6, 7, 8, and 2 in value, because the 9 is changed to the 2 in value. But I don't think that works. Yeah, 5, 6, 7, 8 is... 5 and 8 is 13, 6 and 7 is 13. It's 26, plus 2 is only 28 in value. So the 9 cannot be duplicating the 2. It must be duplicating a 1 on the other end. Okay. And the value would have to be 1 through 8. Plus 1, which is 37. So the 9 must be duplicating the 1. That means the 9 drops to a 1 in the column, that in value, and then you add up all the other digits, which is 1 through 8, which is 36. So 36, it would be 37 then, which means we have 2 3s, and that's for the 2 and the 9. In the 2 in value, and the 9 digit, which is going to be 1 in value. So it's 37 guaranteed. So, and this cannot be 37 here, because, and this can't be 37. So where's the 37? It has to be here. So this is 3 and this is 7. This has to be the 9 and is the copycat cell. So these are not copycat cells here. There's no 9 here. Therefore, since this is 3, this must be 4 here. That's 4. This is... Oh. So this is different than what I had. Okay, good thing I did do that. So that's 30. It cannot be 38 because that's too big for the 2 digits. So this must be 32 here. Which means this is a 2 here. This is a 1. So this is the copycat cell for box 7 and column 2 and row 9. So this is 32 here. The mediums are 3 and 7. And the pinks are 4 and 6. Interesting. So this is 4. Which means the 3 here must be value 3, 9, and 9. So we know 9 has to be one of those 2 digits here, and the other one must be pointing at a 9 somewhere in column 3 as a copycat. So one of these is 9, the other one is a copycat cell. So these are not copycat cells here. Okay, so we don't need these anymore because we've used up everything that we need for that. 9, 4. Okay, so we have all of these duplicated. So we don't need these colorings. Whoops. Okay. So this is, again, can be 20, 21, or 22 here. We know one of these is the copycat cell. We don't know which. Obviously one of these is copycat. It cannot be that one. Well, it could be, technically. This has to be less than 40. No, it could be more than 48. You could duplicate something larger than it, right? Okay. This is 7. So it cannot be 7. It's less than 17. So this could be 1. It could be 2. It cannot be 3 or 7 because, again, they have to be different X pairs. So it could be 4 and 6 here. That's possibilities. So this is a 9, which means we have to have a value of 1 there. Or a digit of 1, I should say. So that's 1. Oh. This is counted as a sum. But if it were not copycat, then the most this could be would be 1, 2 plus 8, 9, 9. Which is 18 plus 8 is 26. Plus 1 and 2 is... Oh, you can't even do 899. It's 789 because this... Well, no, it could be 899. 899 is 26 plus 1 in value plus 2 in value is 29, which is not enough for this sum. So this has to be copycat, which eliminates copycat in the rest of the box and row and column. So this is value. This means this is not copycat. This must be value 9 here. This can't be 9. It's the copycat in column 3 to add up to 21. And that means a 9 has to be there. Well, without 9 as the sums, which is counting these 4. Yeah, maybe we should be showing which ones are counted. So this, oops, counted in column 2 has to be these. Column 3 are all of these. Column 5 is all of those. Column 8 is these 5. These are counting these 3 in column 7. Column 3 must count those 3. And so it doesn't have a 9. That means this values would be at most 4, 7, and 8, which is only 19. Therefore, this has to be a copycat because this can't be a copycat. So this must copy what that is. So it has to be 4, 8, and 8 because this can't be a 9 either way. And 4, 8, and 8 is the only way you can get to 20 here. So this is 20. This is 8, or not 8 in digit. This is an 8 as a digit. This has to be 8 in value. This matches that. So let's also mark what is the value being copied. This is that copied, this is copied, and this is copied. This copies this here. I don't know about this. Okay, so we have copycats now in rows 5 and 6. So these cannot be copycatted. And in boxes 4 and 6. So these can't be copycat. Obviously, these are counted. And these are not counted in... we don't need... Yeah. We just need copycats. So this is an 8 in value. These cannot be 1 or 9. So this must be 3, 7, and 4, 6 as possibilities. So this is a 9 in value. These are 3, 4, 6, 7 because, first of all, they can't be 1 or 9 because of 1 in the column and 9's in the row. And they can't be 8 because of the tentropy line. So they have to be the set 3, 7, and 4, 6. This is copycat, so none of these can be copycat. One of these two must be copycat. Interesting. This adds up to 32. So we have a 9. We could have 6, 7, 8. So we have not, so 32. So the other 3 digits, other 3 values must sum to 21. So we cannot have a 3 here because none of these are copycats, so that's at most 3, 8, and 9. We could have a 4 here. We could have 6 or 7. Oh, this is value 1. So we no, it's value 9, which is still the same tentropy set. 1, 2, 3, 4. This has to be value 1 or 9. Well, it can't be 1 or 9 on its own, so this must be a copycat, which means it's copying this digit here, which has to be a 9. So this is copycat here, because again, this has to be value 1 through 9, because these are the... We have 4 here as a subset, and these must be the subsets 2, 8, 3, 7, and 4, 6, which means this digit has to be a 1, 9 subset as a value, because this is 9 in value here. But we cannot have a 1 here because of 1 in the column. We can't have a 9 here because of 9 in the row. So this must be a copycat, which is copycatting the 9. That eliminates copycats in the rest of the box, row, and column. These are not copycat. So this is a 9 here. So that means we have to go up in value because something's going up to the 9 in value, and the 9's being duplicated twice. So that means it cannot be 42, it's 48 because it must go up 3 digits. So that means the 6 is going up in value to the 9. We have to gain a 3 from 45 to 48, right? So this is 6. So that's a 6 in as a digit for the copycat cells, right? So again, the sum of this would be 1 through 5, which is 15, 7 through 9, which is 24, and then another 9. So that's 1 through 5 is 15 plus 24 is 39, plus another 9, where the 6 copies the 9, is 48. Okay. We know one of these digits is a 5. So this has to be 21 in value. If you have 4, this would have to be then 9, which would force that to be 8. So that's possible. 6 in value cannot... If you have a 6, what would it be? (21 minus 6 is 15. And so you can't have 6, 9. It would have to be 7, 8. So if you have 6, this would have to be 7, and this would be 8. If you have 7, you would either have 21 minus 7 is 14, so it's 5, 9, or 6, 8 as a pair. So you could have 5, 9, or 6, 8 here. So those are the possibilities then. Oh, 6 eliminates 6 here. Okay. So let's go through those again then. These add up to 21 because we have 2 in value and 9 in value here, and this must be 32. So 4 would have to be 9 here and 8 here. 7 could have 5, 9. This can't be 9, so this would be 5 and 9, or 6 and 8. So if this is 4, this would be 3 or 7. If this is 7, it could still be 4 or 6. Never mind. Because it could be 5, 9 there, right? Okay. The values here cannot be 4, 8, and 9. Or sorry, the digits here cannot be 4, 8, and 9. Cannot be 1 or 6. Because we already, or 9, because we have those in copycat cells. Yeah, the copycat cells remaining digits have to be 2, 3, 4, 5, 7, 8. No 4, 8 here because of 4, 8 in the column. No 8 here or 3 because of 3 or 8 in the column. Okay. So this is copycat cell, which means this can't be copycat cell here. So where's the copycat cell in column 1? It has to be here. So it's copying this value. Interesting. Again, 2, 3, 4, 5, 7, 8. No 8 here because of 8 in the column or in the box. One of these 2 is copycat. One of these 4 is copycat. One of these 2 is copycat. Huh. Okay. So now we have to focus on this. Let's focus on that then. We'll go. Uh, let's do dark, medium, light, and yellow. So dark, medium, light, yellow. Dark, medium, light. So this is a light, light. So the tens here, so these must be tens digits also. Okay. So the values here are, well, it could be 19 also. But these are 1 through 4. That yellow is hard to see, anyways. Let's make that light, actually, instead of yellow. And then we'll make these yellow. Because the yellow is hard to differentiate between the green, for me. With the blue being there. Hmm. So this cannot be 6, obviously can't be 9. None of these could be 9 in value. And this is the only one that could be copycatting that. These ones digits are the same set. This light is not any of these. Hmm. Let's see. This is a 9 in value. So if this were 1, what would this be then? You'd have 1, it would be the same as this. It would have to be 48. So this cannot be 1. And it can't be 9, obviously. None of these values can be 9. And again, these are not copycat, so it's the digit themselves. You can't have 1 because the 6 again goes up to the 9 in value. And then you have the values 1 through 5, 7 through 9, and then a 9 duplicated, which again is 48. So this cannot be 1. This could be 2, 3. Oops. I'm using colors now. This could be 2, 3, 4, 5, no 6, 7, or 8, possibly. No 5, because 5 cannot be on a entropy line. So 2, 3, 4, 7, or 8. Hmm. So this is done. We can remove the greens here because that's unnecessary to know. Same with here. We don't need that. We don't need that. we've gotten that information now, and we've gotten this information. So now let's look at these. If this is 7, 1, 2, 3, 4, 5, 6, 7, it would be 11 here. So 7 works. 8 would also have to be 11 because it's not going to add up to anything else. It can't add up to 19 for 2 digits. So that could work also. So 7 works. 7, 1, 2, 3, 4, 5, 6, 7 would have to be a 4. 7 and 4 add up to 11. 8 works. 8 and 3 is possible to add up to 11. 4. How does 4 work? 4 would have a 9 in value and then something else. So that would be 13. We don't have another 9 available. 4, 9, and 8 only adds up to 21. Again, these have to be the same set. So that would have to be 19, which would be 4, 9, and 6. So this cannot be 4 then, because they would have to have 2 6s in the row, which is not possible. So 4 does not work. Right, 1, 2, 3, 4. 1, 2, 3, 4. Would sum up those. And it would be necessarily 13 here. It would have to be the same entropy sets. Which would have to be 19. Cannot be 22 because we can't have 4, 9, and 9 here. And anything greater than that doesn't work. 3. 3 would be 1, 2, 3, and then 1, 2, 3. So it would have a 9. So 3 and 9 add up to 12. So far we have 11 or 19 there. Actually, we don't have a 19 yet. I'm thinking the 3 could be a 19 here, though. Again, 3 would count this, would count the 9. So to add up to, it can't add up to 11. To 19, it would have to be 3, 7, and 9, which it could be. So 3 works. So right now, this is 11 and 19. 2 would have to contain these cells. So if this were 2, obviously this could not be 22. And it would have, you would already have 2. It would count these cells here. That's a value of 9, a value of 9. So that's already 20. So the remaining 2 digits would have to add up to, this would have to be 33 if it's the same set. That means these add up to 13 without a 9. There's no 4, 9. No 6, 7, it would have to be 5, 8. Which would then be 5 here and 8 here. And that does work. So this is either 11, 19, or 33 here. Interesting. This can't be 8 because of 8 in the box. That's interesting, too. So, none of these can be the set 3 and 7. Because what cases where this is 11, this has to be 3 or 7 here. And the case where this is not 3 or 7, it's 2, which must add up to 33. So we cannot have 3 or 7 in the rest of this entropy line. So this was 1, 2, 4, 6, 8, 9. Interesting. We don't know what this value is. It cannot be a 9, though. Oh, so where is 9 in box 9? This can't be a 9 in value because 9 in value would not have a 2-digit sum. It would just be a single-digit sum. So 9 can't be here because of 9 in the column. 9 can't be here because of 9 in the rows. 9 can't be here because of the copycat. So 9 has to be here, which means this can't be 9. This is 6 then. So this must not be 4, 9, and 8 to add up to 21. It has to be 7, 6, and 8 here. So this is 7, which eliminates 7 here. So this cannot be 11 then, adding up. It's either 13 or it's 19 or it's 33 here. 7 here, this can't be 3 or 7, it cannot be 6, therefore it's 4 left for the entropy line. And 2 plus 8 plus 6 plus 7 plus 9 is 32. Remaining digits then, 4 eliminates 4 here. Remaining digits in column 8 are 3 and 5. 8 eliminates 8 as a possibility here. That was actually pretty cool. Anyways, remaining digits. Remaining digits in box 9, we have 1, 4, 5, 6, 7. Okay. 5 cannot be on the entropy line. This could be copycatting this cell there. Okay. So if we have 3, this adds up to 19. Oh, and this, okay, so if we had 3, it'd have to be 7 and 9 with it, which is not going to work. Right, to add up to 19. It can't add up to 11 because 3 and 9 already add up to 12. And then it has to add up to 19, which means this can't be 3, it's 2. So this has to be 33 here. That eliminates 2 and 8 as possibilities in the rest of the line. This is 33, which must, and this is the sum of these 5 digits. This is 2, 9, and 9. That's 30 or 20. 33 minus 20 is 13. So these 2 digits must add up to 13 without a 9. No 4, 9, no 6, 7. It's 5 and 8. This can't be 8 because of 8 in the box. So this is 5. That's 8. That leaves the remaining digits as 1, 3, and 4 in row 3. 8's there. This can't be 2 or 5 then. Okay, where is 8 as a copycat in a copycat cell? Cannot be here anymore. Can't be in the rest of the copycat cells, do not have 8 as a possibility. So 8 could be here or it's one of these two. Okay, that's not helpful. I thought I was going to get some more information. 8 has to be one of these 3 digits. So this is done here. Can this be 40? Potentially. No. If this is 40, that would mean this has to be 41 or 49 as a sum. But that would also mean this has to be 1 as the value in the copycat. And to get a sum of 41, the 5 would have to drop to a 1. Oh, 5 also eliminates 5 here. Can this be 6? If this were 6, we'd have 1, 2, 3, 4, 5, 6. 6 and 2 only add up to 8. So this can't be 6. It's 7 or 8. So again, this cannot be 40 because it would have to be with 41 or 49. This would have to be dropping to a 1 in value to count everything to get to 40 something. And the 3 only drops 2 in value, so that would be dropped from the sum from 45 to 43. The 4 only drops 3 in value to the 1, so that would drop from 45 to 42. And the 7 would drop way too much. It drops 6 in value from the 7 to the 1, so that would drop from 45 to 39. So this cannot be 40 at all. So these are teens, which means this must be 46 here. So this cannot be a 1 in value here. So it's 4, 6, or 7 in sorry, 1 as a digit, because then that would be 1 in value here, and that would add up to way too much. So it's either going to be 4 or it's 6 or 7 here. This is a teen also. But, okay. So we don't need the colorings here anymore. 14 or 16. 3 or 4 could work for the 14 or 16 in value. 2 could not. Or 2? Well, 2 can't be because 2 in the column. So then this is 3, can't be 4, it could be 5, 6, 7, or 8 is possible. One of these is going to have to be a 5. It could be copycatted. Ugh, never mind. Okay. I was thinking that because of that, since one of these has to be 5, it has to point to one of these, but they could be copycatted, so never mind. This can't be 7. If it's 7, it has to add... If this is 7, it adds with 1, 2, 3, 4, 5, 6, 7, that digit, to add up to either 14 or 16, which would require this to be 7 or 9. But we have a 7 and 9 in the box. So this cannot be 7, it's 6. So that adds up with 1, 2, 3, 4, 5, 6, 18 to add up to 14. So that's 14 there. So this is 6 in value. That eliminates 6 in the rest of the box. But this could be copycat here. So this is satisfied also. That 6 eliminates 6 in the rest of the row. Okay. 6 has to be one of these two digits here. In column 7, so if this is 17, this has to be 8 here and 9 here. If this is 13, it could be a lot of things. You could have 5 with that being 8 in value. 7, 1, 2, 3, 4, 5, 6, 7 with that being 6 in value. 8 with that being 5 in value. So those are the possibilities. What about 14 and 16 here? 16 cannot be 8 and 8. It would have to be 7 and 9. Oh, that's not possible. Because we have, this is part of the 1-9 Tentropy set. This is value 9, this is value 9. So this can't be 9 in value. So this cannot be 16 ever. This is 14 then, guaranteed. That's interesting. So 14 would have to have 8 here and 6 here, which is not possible. It cannot be 7 and 7. So this has to be 5 here. So this is a 5, which eliminates 5 there. So 5 plus 9 in value adds up to 14. So this can't be a 9 because of 9 in the row, so this must be copycatting that 9. So that's a 9 there. And again, we have, what digits can it be? 2, 3, we have colors right now. 2, 3, 4, no 5, no 6, 7, or 8. No 4 here because of 4 in the row. So what are the possibilities? So this adds up to, can this be 17? Yes. So that would be 8 and 9 there. If it's 13, it's 8 and 5 there. If it's 13 for the 7, it would require 6 and 7 there. Okay. Remaining digits of box 3, we have 2 through 6. Obviously, no 5 on the Tentropy line. No 6s here, because of 6 in the column. Okay. Tentropy line cannot have 1 or 9. So it's 2, 3, 4, 6, 7, 8. No 8 here because of 8 in the row. No 6 here because this can't be 7 and 6 here because we have a 6 in the box. So this is not 7, this is 8, which makes this a 7. So 1, 2, 3, 4, 5, 6, 7. So that means these two are the ones adding up to 9. So that one's done. This one and this one adds up to 13 or 17. We don't know which. It's 5 or 9 there. 8 eliminates 8 being here. Oops. 7 means this can't be 7 here as a digit. This digit is going to be 4 or 7 in value. Sorry, the digit is 4 or 7. That means this must be 4 or 7 in value. 1, 2, 3, 4, 5, 6, 7. So this is the value here that adds up to this. So it's 7 plus 4 or 7 plus 7, which means this is 11 or 14. We don't know which. 7 here means these can't be 7 along this or 3. So there's no 3 or 7. What are the possibilities? 1, 2, no 3 or 7, 4, 6, 8, or 9. So no 4 or 9 here, no 4 or 9 here. Okay. And this digit could be many things. 7 in value. So say it's 7 in value. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 7 plus 3 is 10. 7 plus 5 is 12, which neither of which are 14 or 16. So this cannot be a 7 in value. It must be a 4 in value. And 4 and 6 cannot be on the same entropy line or adjacent to each other. So this must be a Schrodinger. Or not Schrodinger, Copycat. Apologies. So this is Copycat, which means this can't be Copycat. 8 still needs a Copycat somewhere. 8 needs to be in a Copycat cell. This is Copycat, so no Copycats here, which means this is Copycat here. 8 can't be here. 8 can't be in the rest of the copy. 4 eliminates 4 here, so this is 3 as a Copycat. That eliminates 3 there, so it's 5. So this is 4 and value, which means these are the cells seen adding up to the sum. This cannot be 3. This is 5, 6, 7, or 8. So this is done. This adds up to 7 plus 4, or 4 plus 7, which is 11. This is 9 here, so this cannot be 9, so it's 5, which means this adds up to 13. So this is done here. This is confusing. This is 4 going in value down to 3. So this could be 44 if this is 1. Yeah, we need to take a look at those values. So this is 4, which eliminates 4 in the rest of the box and column. 5 eliminates 5 in the rest of the box and column. 3 eliminates 3 here. So this is 2, which makes this 3. No 2 or 3 here. It's 4 and 6 as a pair. This is a 4, 6 in the 4, 6 pair. So that eliminates 4 and 6 in the rest of the entropy line. 3 eliminates 3 here. This can't be 2 or 3. It's 7 or 8. That doesn't work. Oh, wait, no. We have 4 in value. So that means this must be 8 here to add up to 14. So this is 8. There's no 8 here. This can't be 2 on the entropy line. It's 7. This has to be remaining 8 for the Copycat cells. 3 eliminates 3 here. This can't be 2. This can't be 5 because of 5 in the box. So where's the 5 as a Copycat cell? It has to be there, which makes this not 5. That's 3. That eliminates 5 there, so 5 has to be here. This is 8 and 5. So that's satisfied. This is satisfied. 4, 8, and 2 add up to 14. No 8 here because of 8 in the row. 5 works, adding up to 5 plus 9 in value because that's Copycat there. That would add up to 14. 6. Remaining digit here is a 2. 6 doesn't work. That's 6 and 2 adding up to 6 and 2 add up to 8, and 7 and 4 add up to 11. So this has to be 5 here, and this is 14. Okay. 5 in... Where is 5 in column 2? Can't be here. Can't be on the entropy line. Can't be here because that's a 9, so this is 5 there. That gives us 8 5s. We know where the last 5 has to be. It has to be there. Remaining digits in column 9, we have 1, 3, and 9. 9 can't be here or here, so not 1, 3, or 9. 1. Anyways, 9 can't be either of these. 1, 7, and 9. 9 cannot be here. 9 cannot be here. Where is the 9? It must be there. Where's the 9 in column 6? Can't be here because of 9's in the boxes. Can't be here because of 9 in the row. Can't be here because of the entropy line. So this is 9 there. That gives us 8 and 9s. We know where the last 9 is. It's there. 2 eliminates 2 here. Remaining digits of row 1 are 2, 4, and 6. 2 can't be here, and 2 can't be here because of 2 in the column and 2 in the box. So 2 has to be here. That leaves this as a 4, 6 pair. 3 eliminates 3 from being there. The remaining digits in box 2 are 1 and 4. Row 2, we have guaranteed 7, and then 1, 4, or 6. 4 can't be here because of 4 in the column. 5, that works there, and then we have this. So 8 would have a value of... Okay. 8 would have a value of adding up with 3 in value because this has to be entropy different values from 4 and 6. So 3 and 8 add up to 11. So this would be 11. 6. 1, 2, 3, 4, 5, 6. 6 and 1 add up to 7. That doesn't work because these have to be different entropy lines or different entropy values. And 3, that's a 1's digit, would be in the same set as 7. So 6 and 7 doesn't work. 6 and 1 doesn't work because that's 7. 6 and 7 doesn't work because that's 13. So this can't be 6. So if this is 1, the 4 would drop in value to a 3, so this would be 44. So either this is 8 with both of these are 1, and then this would have to be 6. Or this is 1. This adds up to 44. We'd have 1, 4, and this could be, cannot be 8 here because of 8 in the row. So this would have to be 2. Interesting. Okay. Remaining digits in row... What do I want to do? Column 1? Let's do column... We don't have very many, well, 6s. Let's do column 1 first. So we have 1, 4, 6, and 8. No 4 here, no 8 here because of 4 in the box and 8 in the row. No 8 or 6 here because of... So one of these has to be a 4 here. Okay. Remaining digits of row 5 are 1, 2, 3, 4, and 7. This can't be 2 or 7 because these have to be distinctly different digits. And so this one sees both 2 and 7. Ah, we have a 1, 3, 4 triplet. This can't be 7 because of 7 in the column. So this can't be 4 because one of these is a 4. So we have to have a 7 be one of these two. We have a 1, 3, 4 triplet in column 4, which eliminates 1, 3, 4 in the rest of the column. That leaves us with 2, 6, and 7. in column 4. No 2 here because of 2 in the row. Unfortunately, this doesn't give us any more information. This copies that. This copies that. This copies that in value. And this copies that in value. This copies that. This is also being copied. And these copy each other. Okay, column 5. Maybe we should have done that from the start. 3, 4, and 7. No 4 here because of 4 in the row. No 3 here because of 3 in the row. No 4 here. We have a 3, 7 pair in column 5, which eliminates 3, 7 in the rest of the column. So this is 4. That eliminates 4 from being here. Where's the 4 in column 1? It must be here, which eliminates 4 in the rest of the row. So that means, where is the 4 in column 4? It must be one of these two, which eliminates 4 in the rest of that box. Okay. Where is a 7 in box 5? Can't be here because of 7 in the column. Can't be here because this sees the 2, 7 pair as copycat cells. So it has to be one of these two, which means this can't be 7. That's 1, which means this can't be 1. That's 7. Remaining digits in row 4, we have 3, 6, and 7 here. This can't be 7 because one of these two is 7. So it's 3 or 6 here. We have a guaranteed 7 there. Remaining digits in row 6. We have 1, 2, 6, and 8. No 8 here because of 8 in the box. No 8 here because of 8 in the column. Oh, where is the 8 in column 2? Can't be here because of 8's in the rows. Can't be here because of 8 in the box. Can't be here because of 8 in the row. So 8 has to be here, which means this can't be 8. This becomes a 1, 6 pair. That eliminates 1 and 6 in the rest of the column. So this is 8. 8 plus 3 adds up to 11. And therefore, this can't be 2. Can't be, we don't have 1, 9, 2, 8, 3, 7 available. This must be 4, 6. Can't be 4 because of 4 in the box, so that's 6, which makes this 1, which makes that 6. 6 eliminates 6 here, so it's 3, and eliminates 6 here, so it's 4. 4 eliminates 4 in the rest of the box, so this is 1. No 1, 4, 6 there. It's 7. This can't be 1, 3, or 7. It's 2, which makes this 7. So 7 eliminates, this can't be 2 or 6, it's 1. No 1 or 6, 7 there. It's 6, which eliminates 6 there, so it's 4 and 6. 1 eliminates 1 here, so it's 7 and 1. 7 eliminates 7 here, so it's 2. 1 and 6 eliminate 1 and 6 there. It's 2. That eliminates 2 in the rest of the box. It's 1 and 3 as a pair. 1 eliminates 1 in the rest of the row. So this is 3, which makes this 1, which makes that 3, which makes this 7. That's 6. 6 eliminates 6 there. So it's 7, which makes that 3. 3 eliminates 3 here. 1 and 3 eliminate 1 and 3 there. So it's 4, which makes that 1. And the rest is just normal Sudoku. We have 2 missing there. This is 3. That leaves this as a 4, and that's a 6. And that's a solution. Yeah, fairly straightforward. I did like the logic for the break-in. That was a very interesting logic there of what the periodic sums had to be. Anyways, I hope you enjoyed this solution or this solve, and I'll see you next time on Frank Puzzles. Take care.